Hello, and welcome again to the ACADIA 2021 Realignments Towards Critical Computation Conference. My name is Jose Luis, and I'm a lecturer in architectural technology at the Harvard Graduate School of Design and conference co-chair and part of the workshop team who made or facilitated the workshops that happened in early September for the ACADIA conference. I would like to introduce my colleagues and my co-chairs who also helped in making this event happen. I would like to welcome Dr. Benas Farai. I would like to welcome June Grant, and I would like to welcome Bernal Noel as workshop co-organizers as well. It is a pleasure for us to welcome you here today. We would like to begin by thanking our sponsors and the ACADIA community for making this event possible. This year, we were honored to count with 219 workshop attendees across 31 countries, with an overwhelming majority of students led by 37 workshop leaders who are today here in this presentation and across 13 different workshops. We were able to open 17 grants to NOMA, NOMAS, Mexico students, and international students, thanks to the funding provided by one of our sponsors, Autodesk. We want to make sure that a few things are clear before we start. First of all, this session is being recorded and it will be available offline in the future. Links to these videos will be provided after the conference. This session is also being streamed live right now on the ACADIA YouTube channel. In this event, only presenters are able to participate and broadcast their video and audio. Webinar attendees are able to watch the session and contribute via the chat and via the Q&A that you can see on the top right side of your screen. Everyone is welcome to use the chat and the Q&A functions, but we kindly ask that you respect and you observe our code of conduct. If attendees have specific questions for presenters, please use the chat and please use the Q&A, and we will relay those questions to the presenters today. Thank you for your cooperation, and we hope that you enjoy this ACADIA 2021 session and the workshop presentation that we're going to be doing right now. Pernell, I'm handing it over to you.
All right, thank you very much. Jose. Hi, everyone. My name is Bernal Noel, and I'm also a co-chair of the ACADIA workshop program this year. I'm an assistant professor at Georgia Tech and visiting professor at the University of Stuttgart. Like last year, this year's virtual format enabled us to offer 13 two-day workshops, which occurred almost 2 months ago on September 11th and 12th. Workshops were done earlier to make it accessible to students who might be able to learn new skills and tools at the start of their semester. It also allowed us to showcase the work at the beginning of the conference, and by leveraging our remote format, we were able to bring together an incredible group of workshop leaders, researchers, practitioners, innovators, and artists from multiple countries and regions across the world. Through both curated invitations and an open call to the ACADIA community, a range of workshop topics were identified with the goal of leveraging long-distance collaborations, remote fabrication, and innovative software. I'll now pass on to Benas.
Thank you, Bernal. Thank you, Jose. Hi, everyone. Welcome back. My name is Benas Farai. I'm also one of the co-chairs of 2021 ACADIA workshop program. Today, we have the great pleasure of recognizing the hard work of both the workshop leaders and participants and show off some of the works that it has produced during this time. Each workshop team has prepared 3 minutes video documenting the workshop and the results, and we are really excited to share that with you and discuss that today. Given the large number of workshops and workshop leaders, we organized the workshop into 4 separate thematic groups. For each group, we will play videos in the background while we have 15 minutes conversation after. with the workshop leaders. It will be a kind of rapid fire conversation, but we hope that it will be fun. And hopefully, if you get a chance, we will go to Q&A at the end. So as you can see, we have 4 thematic panels. The first one starts with artificial intelligence, in which we have 3 groups. The first one, the workshop 1, latent morphologies and disentangling design spaces. Workshop 3, collaborative AI, human plus AI forms, and workshop 10, the generative game. So let's go to workshop 1. And I'm going to invite the workshop leaders of workshop 1, Daniel, Shermeen, and Manus, to join us. This workshop explores ways of connecting different neural networks, for instance, CycleGAN and StyleGAN, to explore search spaces of architectural inspiration. I want to invite the workshop leaders of this group to give us a brief summary while we are playing the video, to tell us a little about what was this workshop about and how anything about the workshop you would like to share with us. It would be amazing to hear from you. Daniel?
We are waiting for Shermeen. Can you make Shermeen please present her?
Sure.
Or...
She is joining on a stage.
Yes, hello, can you hear me?
Yes, we can hear you, Shermeen. Welcome.
Thank you, Behnaz. Thank you so much. Thank you for the great introduction. I'm Shermeen Youssef. I'm an assistant professor at Florida Atlantic University, teaching along with my colleagues, Daniel Bolojan and Emmanuel Vermiso. The 3 of us gave this first workshop that is introduced today. Basically, our workshop was, as Behnaz mentioned, is about exploring ways to connect different neural networks, example, CycleGAN and StyleGAN, to explore the search space of architecture inspiration. Our particular semantic references served as input for a pre-trained network, which outputs data for further investigation using another neural network. So the data sets will focus on exploring various resolutions of the urban domain and assess possibilities for emerging patterns, etc., through interpolative and extrapolative strategies. So from a process point of view, we are interested in identifying relevance between certain types of neural networks and their ability to access creative potential in a targeted and/or heuristic open-ended fashion. So it's important to consider the capacity of these nested workflows to alter our immersion in the design investigation by accessing a design space that is otherwise beyond the designer's reach. So by moving beyond rule-based defined design spaces, AI's feature learning capabilities combined with the incorporation of additional inspirational sources, which is outside architecture, enable creative exploration within an extended space. So our perception of these expanded design possibilities is crucial because it might point to the direction of future search. Thank you.
Wonderful.
And I think our my co-leaders, including Manus, can add more to the.
Thank you, Shermeen, and good afternoon, everybody, or good morning, depending on where you are. So I just want to add that in the interest of time, and considering that Daniel, Shermeen, and I have taught similar workshops in the past, this was a much shorter time frame. So what we tried to do is to combine these sort of interconnected networks by ways of the computational power in terms of, and the expensive, the cost in terms of time that each one of these networks requires. For example, understanding that a StyleGAN requires, can afford a more expedited training process, we allowed the participants to lively interact with this kind of network, whereas we introduced pre-trained CycleGANs because these are the type of GANs which require more time in terms of training. And so by working through these combinations, we had this sort of nested processes of being able to curate data sets for the kind of networks that we could afford to train within a day or so, and then plug those into those pre-trained categories of cycle GANs, and then move on to other parametric platforms like Grasshopper for final massing, production of massing options, and so on.
Thank you, Manus. Is there anything, Daniel, we would like to hear from you?
Yes, so I'm going to be very brief. Hello, everyone. It's great to be here. So just a few things to add to what Manus and Shermin already discussed about. So for us, it's very important in a way, and our approach to architecture is mostly, we are looking at architecture from this kind of perspective of a multi-layered system. And we always understand the outcome of architectural process as this kind of codependent on multiple interrelated systems. So why that it's important for us is it's important because most of the times we have this kind of interpretation of AI in architecture as one system that in a way flattens all the hierarchy that you have in an architecture project, for example. So then for us, it's very important to look at ways to address different architectural layers or systems, and then how they relate to each other. And another aspect here when it comes to this kind of idea of interconnected processes is this kind of idea of agency. How exactly we afford this kind of agency to designers, and which is the degree of that agency that the designer has. So by designing these kind of processes, then we have different degrees of agency that the designer can have. And I will stop there, and we can continue the discussion afterwards. Thank you,
Absolutely.
everyone.
Thank you, Daniel. I mean, there are so many points in your conversation from each of you already that it's enough points for our discussions after. Let's move on to workshop 3. Zach and Xinhua, if you're here, this workshop was really about exploring the intersection of game and AI as a novel way to approach architectural, participatory, generative design. I want to invite the leaders of this group to introduce yourself, say a few words about your workshop. Over to you.
Thank you very much for the introduction. So I'm Xinhua, and unfortunately Zach is not here. But we are based in Vienna, and we are designer researcher. And basically, so what we did in this workshop is essentially combining game and reinforcement learning or machine learning agent in a way to think about how perception of us or human can interfere in this process to collaborate and work with AI. In such a way as looking at how we collaborate with AI in training, that not only us, but AI can learn from user perspective, from the player perspective. And AutoCAD can set up the goal and parameter and let AI to pick up what's given and try to get the most reward. So we are asking how does user can be part of it, to be part of the parameter and to tune how AI can learn. So essentially, this workshop aimed at constructing this interrelation between AI, human design thinking and articulation, and AI-informed form finding in the future of design production. And often works that interest themselves with machine learning are designed and visualized from an alien perspective, that of an object on an empty field, and seen from far above and outside of human field of view. So what if we instead operate on this in a micro scale, instead of forming the whole architecture, but just focusing on the element of architecture and on the single experience of a space? So the CES workshop will apply the reinforcement learning in Unity and take advantage of the Unity's gameplay function to create this immersive experience during the generation process. And so basically the students are designing objects. What you see now, there's a various types of objects and way to let the AI interact with the objects that are in charge of the design, and they will then be the player. The student will be the player and user to experience the design environment generated from AI. They can also play each other's game and make critique, right? They won't be able to get AI that is fully trained, but training in process, so we can really sense more sensibility how AI is performing. So I think over the workshop, what we achieve is that we then shift from making decision based on the outcome of AI, but really now we are based on the process of the AI, which help to further define how AI should be added, or how, for example, the reward should be added, how the methodology should be added to let it learn to build better according to the user. I think. So I think that's all what I have right now. Thank you very much.
Thank you, Xinhua. Let's move on to the workshop 10. I'm assuming we don't have them here. Workshop 10, the generative game. Unfortunately, the leaders couldn't attend, but we have a short video that we can play. So this workshop actually covered a series of hands-on advanced 3D machine learning techniques for generative architecture design, including but not limited to 2D latent walk technique and 3D GANs and reinforcement learning that we have a very short video from their leaders. Maybe here we just stop the sharing a screen and have all the workshop leaders for these two workshops to discuss some of the things that you have done during this workshop. In particular, I'm really curious to know about this influence of AI on the role of architects. How do you see AI is changing the role of what we know as architect or designer? And maybe this will be addressed in terms of agency. Like is computation and AI in particular the agency of the designer or the architect? How do you see that relationship between the person who's designing and this type of computational systems?
So I can say a few things, and maybe I start the discussion. So for us, the understanding when it comes to agency is that depending on kind of networks that you're operating with, you have different degrees of agency. Certain networks, they limit the agency of the designer and the input of the designer mostly to just curating data set. And for us, that's not necessarily the best use of using this kind of networks, and it's a very limited degree in a way of agency that you have there. So then for us, what is important is to look at which is the mode of interactions and then the designer can have with the machine, with the AI, for example, and which is the level of intention that I can encode, which is the kind of process that I have to develop in order to increase that kind of level of agency or decrease it. So for us, this is the interesting side of things here, like how exactly we play with that aspect. Different kind of networks for different kind of degrees of agency and different kind of processes that we develop there for those all different degrees of agency. And also it's important to look at things as design. It's for us, it's a multi-layered in a way process. And there are a lot of topics that they might be addressed in a 3D manner. There are a lot of topics that can be addressed in a 2D manner, and they can be in a way developed, or a project or design project can be developed in that kind of way as well. Yeah. When it comes to the future of the architect, when it comes to AI and this kind of topics, I think we might end up with a different kind of architect. Probably we are not talking about AI replacing, but I think we are going to talk about an architect that's augmented in a way by AI. And then I think it's just a matter of us, how we define in a way that kind of augmentation take place. Yeah, it's going to be an augmentation that mostly automates a lot of processes, and then we just have time for design, or it's something more deep where actually we start to have deeper insights and ideas about developing architecture.
Thank you, Daniel. I just wanted to add a couple of things very briefly. First, regarding the Benaz, your question about the architect's inspiration. And I think with regards to also extends to the architect's role in the future, one thing that's happening with AI is that it challenges the limits of our own inspiration and what we've considered to be, for example, creative and so on. So if we look at the way that we process and interact with different tools, then, or whether we look at our perception of what a feasible solution is, I think in both of these ways, an AI has the capacity to help us restructure the way that we think about it. For example, by expanding the search space or by challenging the correctness of what we feel is creative or not. And my second comment was regarding the actual agency, and relative to what Daniel was talking about. One of the reasons why we want to work with interconnected networks is because they expand this sort of interface between the machine and the human designer, which allows more potential for both reflection of this kind of how this interaction works, as opposed to having this sort of one or two step process where input and output are this potentially remain this, let's say, more static this static framework, right? Because we would be expecting the perfect solution from a machine, as opposed to really interacting with the machine back and forth and challenging both what we want to input as well as our expectation for the results.
And if I may add, sorry, certain points, because I really like the question, Banaz. I think this agency aspect has multiple levels, like what Daniel was saying about the levels of agency within the process, and also the bigger question of the future of the discipline and with AI automating the design activity. I think what I see is that this kind of like from my perspective, the past few years has shown this great interest from architects learning and applying those deep learning and generative deep learning models in design. And this kind of aspect of these models are doing things independently, right? So for example, StyleGAN is very unsupervised network. But then I think with the agency aspect is that the way I see it is the more competence as architects we have, and we are skilled in understanding fully those models and these networks, and maybe computational kind of background would help in controlling the process, and also in defining where as human agents, where we stop and let the network train, and where we interfere and have this kind of data set curation or connecting a network to another. So I think the aspect of celebrating that AI is designing, I think it might be a little bit misleading, because I think we have this critical perspective in the workshop and in the approach with the using of AI. Our design process is actually getting more complex and more demanding. It's taking more time, and this human machine collaboration interactive model is actually very interesting, but also very complex. But I think it's like it's not just the machine is learning, and I think as architects we're also adapting to this new design process, and the skills and computation background, and also the experimentation would help us in terms of defining moments of control and agency, and letting the models also train on their own at some points. And I see the future is that architects are actually also AI and a researcher, and also computationally competent.
Thank you. Maybe just a few words from Qinhua and your thoughts on this, a question of agency and AI.
Yeah, I totally agree with Sherman, what Sherman said about that there's two aspects, one inspiration and one very critical assessment. And I think, yeah, there's two aspects, what AI bring to rebuild the agency and to rebuild this interaction and connection in between design process and the user. I mean, one way, like what Mano said about the inspiration aspect, that the heuristic process and the relative low resolution generated from this process might look like it's problematic, like it's not ready and not guaranteed to obtain the best performance, but it in a way help the inspiration of designer and the rationalization process that allow us to criticize our own method that is deploying this process, whether the reward are setting right in the case, or whether the input data contain all the necessary information. That's like recreate the new criteria of architect. And in another aspect, it become an analytical tool that when we build a hypothesis to find solution, we build a tool that can help to find whether there's a problem in this process, whether, for example, in my case, the AI might start to do something differently, but achieve the same goal. And that put a question on our condition, on our hypothesis, whether we miss something or whether we miss some data that we need to reintroduce.
So I do want to pick up on certain things here very quickly. I know that we have to move on soon, but I want to ask one thing in terms of like there is architecture discipline and then there is architecture profession. How do you see the type of use of AI algorithms could affect profession of architecture? Would that cause one day the architects, basically the architecture firm needing to use any architects in their firms because all the systems are basically automated through the use of artificial intelligence? Would that ever be a sort of a feasible future? Would you be worried about it? I want to hear some insight on that.
I'm just thinking about the quintessential quality of an architect traditionally, which has been this sort of ability to synthesize, right? This synthetic potential of seeing things and orchestrating things rather than directing or technically directing things. So the short answer is that I think architects are more than just very, very skilled technicians in specific tasks, and they can be these sort of coordinators of the process. It kind of makes me reflect back in 2004 and one of the older ACADIA conferences on fabrication when Kieran Timberlake gave, I think, a keynote which was talking about how the CNC fabrication, which was beginning to emerge, was promising this sort of relocation of the architect at the center of the production, at the center of architectural production, something which has been displaced since the 19th century or even earlier, when the architectural design was separated from architectural construction or the implementation through the introduction of the contractors and other professions which were mediating between the design ideation and the implementation. And I think in a similar capacity, if architects can, going back to Shermin's comment, remain computationally competent, I think we have the capacity to stay in this center of production and coordinate the AI frameworks that we design. So it's yes and no, but it depends on really how we approach it as designers.
I agree. And if I may add, and I try to be short, but Behnaz, it's a great question. And it's, I think I see the trend or the what's happening in the profession is that there is this kind of celebration of AI and an attempt to use AI for performative aspects. For example, prediction and estimation of certain metrics and measures, like in terms of environmental aspects or other modeling and simulation, and AI can be really quick and fast and gives you real-time analysis, right? But I think the design process itself, because it's very complex, there might be still a need for designers or architects, but it's also being like, I think AI in general is being very commercialized and celebrated in industry and in practice in terms of, yes, AI is automating many disciplines and occupations, and it's like the architecture firms might actually replace an architect who doesn't know AI with an architect who knows AI. But I also see that the performative AI is already there and it's happening in the profession, so there's no question about that, and it's really increasing exponentially. But the exploration part and the creativity aspect of AI, I think we still need designers at this point.
Do we still have time? Can I add a few?
Yes, please do.
So probably I'll add like mainly 3 points, maybe. So one point is, so this question, I think it's a valid question, but I think things are going to happen way in the future, more than further away than we think of. Yeah. Many times when we talk about these questions, we are actually thinking of like in next 10, 20 years, which I don't think is really there yet. I think one big aspect that we have to look after is convergence of technologies. So right now, we see social media and AI, and actually AI is powered by the success of social media. But in architecture, we don't really have at this point a sort of technology similar with social media that will collect data the way the social media is collecting data. So we don't have, in a way, that kind of data that will help, in a way, architectural AIs to develop a lot. Yeah, we just have images and other kind of data sets. Yeah. But I think unless we have like more data set that really describes the entire architecture, the architecture of a building, then until then we don't really can talk about an AI that actually replaces something. Probably we talk about AI replacing here and there a few tasks, yeah, but not more than that. Then I think also another aspect that we have to look at, I think also we have to understand probably the architect is not going to be the same kind of architect that is right now currently, but probably the architect will be this kind of person that actually searches things more than actually designing things. Yeah. So it's very similar. I think Neil Leach is the one who introduced, or at least I heard from him, this idea of, if you look at in photography, so you have the master photographer, in a way, traditionally speaking, you had that master photographer placing the tripod, taking the perfect shot, waiting the perfect lighting to be perfect and so on, and then it will take the shot. Yeah. But right now what we have is you have a photographer that goes out and takes a bunch of images, like dozens of images, different light conditions, different exposure and so on, and then comes home and starts to, in a way, select, sort, filter, and compose and combine, in a way, these images. Yeah. So I see, in a way, also design probably is moving in that kind of direction, where it's mostly a process of searching than a process of what we call right now designing or creating. So the third point that I wanted to make here is also this aspect of if we end up with AI replacing a lot of the task of the architect, I think I would like to take a positive angle to it, although there are some negative aspects, but I'll just point to one positive aspect. I think that will democratize, in a way, architecture. So right now, what we have is, if you're a young architect that tries to build a practice, it's very hard for you to really have a serious portfolio to convince clients to award you a contract, a project. Yeah. So I think once we have this kind of toolkit in our back, like different AI tools that we can use, perhaps to generate building design and so on, probably that will lower, in a way, this kind of expectation, because suddenly a team of 2 probably is able to generate what a team of 20 people is able to generate today. Yeah. So in that sense, I think that will really help then with a lot of also people that don't have necessarily the privilege, in a way, to be born in a certain network, a certain family or something. Yeah. And that will open up, in a way, then the doors for more architects to actually have their own practice and really realize their architecture, their ideas.
Wow, that's fantastic. Thank you all for your inputs. Unfortunately, we have to move on to other workshops, but hopefully at the very end, if we can, we come back all together again. Thank you to all of you for the amazing work, and thank you to all the students of these workshops. I pass it on to Bernal.
Thank you.
Thank you, Banaz. Thank you very much. All right, we're gonna get participants or workshop leaders from workshop 6, 7, and 8 on the stage with us. All right. Okay. And I'll just begin sort of describing for workshop 6, which was by Ozog Bertog Kapunaman, Benai Gersoy Toykach, Semal Kore Bingo. Then workshop 7 was around enhancing fungi-based composite materials with computational design and robotic fabrication by Jonathan Desi Olive, Omid Olian, and Ali Sayed Damadian. Then workshop 8 around knitted group, scaffolds for living spans by Marian Popescu and Robin Oval. Are all our workshop leaders on stage? Yes, I think I see everyone. Okay, so we can begin with workshop number 6. In this workshop around crochet and computing stitches, participants were sent around the world were sent crochet kits to collectively design and crochet branching spatial structures. So workshop leaders, you all want to tell us a little bit more about your workshops?
Sure. So thank you for the great introduction. So my name is Özgüç, Oz for short, and I'm here with Benai and Koray, my co-leaders of this workshop, co-crocheting. So this is actually a workshop that is based on a previous research on generating crochet patterns for 3D objects that were modeled in Rhino environment using NURB surface definition way back in 2017. And we kind of wanted to revive that project to see how where we can take this idea of customized fabrication and see if it can actually enable somewhat of a distributed fabrication while it's still kind of incorporating little minute details that might affect the fabrication quality overall. And throughout the workshop, we basically generated a very simple geometry-based decomposition of the NURB surfaces using UNV surface divisions and so on. And as you mentioned, also all the participants were sent a kit of crochet yarn, crochet hooks, and along with some tutorial videos to kind of get them warmed up to crocheting. And the first half of the workshop, we were looking into form generation using some kind of a branching structure idea, and we were able to pinpoint one geometry that was doable within the time frame that we had, and then we transitioned into building what basically using the software or the little piece of algorithm that we provided to geometrically decompose these geometries into first crochet rows, then crochet stitches, and kind of try to find all these little increases and decreases that kind of make up the form.
All right, Osgood, if you want. Thank you very much, Benai. If Benai doesn't want to say anything, we could move on to workshop number 7, and then we'll all chat. Okay?
Maybe just to add to what
Sure.
you said, Bernal, and it's great to see you, by the
Great
way.
to see you too.
So yeah, what we did is the branching structure that the participants collectively designed were discretized into individual pieces, and then the participants actually crocheted those pieces, and they sent us back. We're still missing a couple of those, but then the goal is to, when we have all the pieces, we're going to assemble all of them into one single structure. So we're still waiting. Some of them are still in transit. We had participants from 7 different countries, some including from from Middle East. So we're still collecting those, but yeah, I just wanted to add that fabrication part of the workshop.
Beautiful, beautiful. Thank you, Benai.
Thanks.
All right, workshop number 7. So this workshop explored the capacities of computational systems to develop an integrated design to fabrication workflow for fungi-based materials or micromaterials, as were being described by entangling mushroom mycelium around agricultural waste such as hemp or soy. So we have Jonathan with us. Jonathan, Omid, Ali.
Well, hello. Hello to our hosts and the audience. So before I introduce the team, our video has a very nice voiceover narration of the workshop. We can't hear it right now, but if we can make that work, that would be great. But until then, I can
constructive paradigms of fungi-based materials through computational structural design, robotic fabrication, and mixed reality fabrication. Preliminary experiments have revealed that strategic reinforcement strategies with natural fibers and textiles results in performative benefits that could drastically expand the range of possible real-world applications. Based on these findings, our workshop invited participants to conduct an at-home experiment to design and grow a small-scale, fiber-reinforced mycelium composite slab structure and test it to failure. During the workshop, technical talks and software tutorials were given by the team of co-organizers, covering the essential skills participants would need for conducting the at-home experiments. A custom workflow in Grasshopper was introduced that generates fiber-reinforcing patterns for a mycelium slab structure to be tested in the experiment, based on a highly flexible set of design parameters. As a speculation on how robotic fabrication might be used to deploy the custom design reinforcing patterns, the workshop introduced KUKA PRC. Participants learned to simulate robotic movements determined by the reinforcing patterns. Where available, participants received a kit that included materials needed to grow a reinforced mycelium slab specimen and later test it to failure. The organizers demonstrated a tactical approach for participants to physically make their reinforced patterns by sewing them by hand into a grow mold, guided by the free smartphone app, Hologram. The molds were later packed with inoculated hemp fibers, letting the reinforcing to become integrated into the mycelium composite matrix. Due to the time it takes to procure and grow mycomaterials at the time of the conference, the participants are now beginning to grow their reinforced slabs. We'll be happy to return next year to report the results of their load tests and share our continued work on enhancing fungi-based materials. We would like to thank the organizers and the board of ACADIA for their support of our workshop. Thanks again to Karamba 3D and the Association for Robots and Architecture for sponsoring participant access to their software, and thanks to OpenMyco for sponsoring the mycomaterials. Finally, we would like to thank our participants all over the world for their enthusiasm for mycomaterials and their energetic engagement in the workshop.
Thanks to the great narration by Jonathan. So my name is Omid Olian. I'm a researcher and computational designer. The other team member is Jonathan Desi Olive, assistant professor at Kansas State University and founder of the research lab Myco Matters. And Ali Said Ahmadian, who is designer and robotic and digital fabrication specialist at Evanscape, New York. Yeah, this workshop is built on the fascinating research that Jonathan and his team is doing at Myco Matters at Kansas State, and kind of emerged from the extended collaborations between Selman and Myco Matters and Evanscape, kind of emerged from those conversations, and is addressing a specific question in enhancing the structural capacities of fungi-based composites, and it's their application in at architecture scale.
All right. Jonathan, you want to add anything before we move on to workshop A?
I think we can just save it till the conversation.
Okay, I'm happy to hear your voice on that mic, though. I just
likewise.
Okay.
Yeah, it's great to see you. Great to see some familiar faces.
Oh gosh, nice. Okay, workshop number 8. If we can play this slide. This workshop explored the design of deployable knitted textile membranes as scaffolds for climbing plants. The knitted textile is designed to guide the growth of a plant into spans following principles of structure and placing material where needed. So we have Mariana and Robin, I believe.
Yes, I think you only have me at the moment.
Okay.
Robin is not here.
Mm-hmm.
You've done a marvelous job to describe this, actually. So what we tried to do was to have a nice combination between the research that Robin is doing on topologies, on placing specific features, and making sure that those can be, that singularities and segmentation and how you divide structures according to structural principles, or where you would want to have more strength. can be nicely combined actually with the idea of having a knitted formwork, which is part of the research that I'm doing. Only this time we decided that it would be actually quite nice to do this in a playful manner, to look at the material not just as a formwork for some sort of concrete or some other cast, but to think of it as a living root bridge, or think of something that promotes growth. So in that case, it would be a little bit of the reference for that were the living root bridges of India, where you kind of have these plant roots that are being forced to, well, not forced, they are being guided a little bit to grow over waterways throughout an entire amount of time. So we were thinking that actually if we could translate that growth or that strength of where you would want to have a thicker root or a better supporting root or a lesser something else into a guide through this type of textile, that would be quite interesting to explore. And our initial idea was to have this actually be done by the participants and then knitted and have, well, not trees growing on it, but maybe some of these plants that grow quite fast. We're still planning to do this once we get access to the equipment. What happened during the workshop actually is that we took a lot of time on the form finding side, on really having participants understand how to work with tensile systems, how to form find something, and then how to play with forces, how to introduce those ridges, how to introduce places where you would need to carry more load and use those loads to shape those designs, imagining that those might be roots that can carry a little bit more. And then I guess that's kind of the summary of what happened.
Awesome. Thank you very much, Mariana. I want to say one thing that we all loved about all of you was the fact that we were making things in very distributed ways in the homes that we were all in, or have been over the past 2 years. The fact that you all were mailing things to people, doing these distributed ways of physical making was wonderful, beautiful, and congratulations on getting all of this done. Okay. So one question I have for everyone is, how, based on some of the results and the things you probably learned from conducting these workshops in September, how have they probably generated or given you more provocative ideas for your projects, as we are attempting to frame in this conference terms around critical computation? How do you think your workshops further enlightened your project, and probably for today might have you been thinking through critical computation? Anyone can start.
I can mention if anyone wants to.
Sure.
Well, we thought with the algorithm that Oswich designed in his undergrad thesis, while opening this algorithm to anyone all around the world, we suddenly had a reach of a global audience with very little knowledge of crafting, which is the crocheting, and we let them understand the process of having this digitally designed form into a very crafty way of doing fabricating design. So suddenly everyone who attended this workshop that we did had the skill to design anything on a Rhino screen and then try to fabricate it with their hands, which the algorithm works. The output according to your crochet skills, let's say, in a very simplistic way. So you are being able to transform or take out a knowledge of the crochet patterns we're talking about here, and you're able to create anything out of thin air, while you don't need a very complicated CAM like a 3D printer or a CNC milling machine. You just have the knowledge of transferring that digitally designed object into your hands and into a crafting manner, which we thought was quite interesting for everyone to have this interesting experience with us. We had this moment with everyone that crocheting on their screen, like old nannies in the community center, but it was quite engaging, and everyone was having fun while literally fabricating something through the workshop. That was quite interesting and enlightening for us, I think.
Nice. Jonathan, Mariana?
I can add. I will actually jump onto what you said, Samal, because I think that's really beautiful. Usually, I like to say that because we have that developing a sort of pipeline from digital design to fabrication means that we can just send the instructions out to machines and things, and that's very easy. And that's actually a very nice. So we still experience this bottleneck of needing a machine, but you didn't, because because you could actually literally send the instructions everywhere. And I think that's really, I think that's really beautiful about your workshop, for and watching what happened now. So congratulations. I wanted to add that for us, maybe I think it was the learning point was a little bit more on saying, understanding that you can work on it in the same way on a global scale, but maybe that means that there are also certain challenges, because we had participants in the workshop from all over the world on different time zones, and you'd kind of have to get them to all work together or work on the same product. And it's very beautiful because we can democratize things in this way, and we can democratize that knowledge, or that but at the same time it's really challenging to bring everything together and have people work together in this way, even though there's theoretically more access. So somehow for us, one of the takeaways was this: how could you actually still make this work as smoothly as in person then, and on very many different levels?
Absolutely. Let's hear from Jonathan to take us home.
Yeah, to add to that, I like what you just said about democratizing. I think with our workshop, what ended up happening is that the computational design, the simulation, that was actually the most accessible out of anything. We had sponsorship, graciously donating, sort of access to software for our participants. But because we had a material thrust, actually it was in the material where we had our issues, right? So number one, we're working with such an extreme material as far as the sort of status quo of materials in architecture and design, that doing things like providing access to mycelium materials in the Middle East was not inherent. So yes, we're working with people there and trying to get it. So it's interesting when you talk about democratizing, is that actually the computation is pretty democratic. It was just as easy as sending a Google Drive link, and everyone in the world, from Australia to Iran to Ohio, had access to it. But we really did have this hang up when it came to providing, number one, a means of fabrication. So not everyone has a robot. But also the material itself. And so I found that was kind of what sort of came out of it, is that actually the computation is pretty much where we need it. We can kind of provide equitable access to this thing, but the materials are somehow not there.
I like that. I like that thought very much. Unfortunately, we have to wrap up. I want to say thank you so much, Banai. Thank you so much, Jonathan, Omid, Ozgur, Mariana. Beautiful work. I'll now pass on to my partner, Jose.
All right, beautiful. So I'm going to introduce the third block in this afternoon, which is one that we have seen around the general topic of robotic fabrication with augmentation. The idea is we were thinking about how to make things with digitally enhanced and augmented with digital technologies. The workshops were distributed collaborations, remote robotic assemblies, and augmented architectural details. But I would actually like to invite the workshop leaders to introduce the workshops themselves. So I'm going to move on to the first video. This is remote robotic assemblies. Oops.
Hey everyone.
Yes.
You can hear me? Great. Okay, well the video's playing here, but just want to introduce the workshop. It's the remote robotic assemblies workshop, and as the name would imply, really the thrust of this workshop is to practice the process of fabricating a structure, but in a remote context. You know, and as we've all experienced over the last year and a half, remote work is more prevalent than ever, and using the Compass RRC set of tools for the Compass framework, we wanted to get the participants to practice actually designing their own robotic process and then executing it live using our mobile robots here in Princeton. So the participants would practice with the tools, planning the paths for this space frame structure that we pre-designed for them. And then during the workshop, they would send commands to us, which would then get executed by the robots. So we had a live cam footage of the structure being built, and what you can see now on the screen is a time lapse of this process. Now, of course, this is happening very quickly, but as you can imagine, during the workshop, this was a much slower process. You know, each participant took some time to do the path planning, make sure that it would work, make sure that the structure or the path that they planned was feasible, and then executing it after. Something that we didn't really explore very much in the workshop was or discuss directly in the workshop was the idea of this sort of collaborative process. But on our side, our research is really about how we can use more than one robot in a cooperative manner to, accomplish these complex assembly goals. So in this case, we wanted to build this spanning structure, starting from one end and moving to the other end, in a way that didn't require any formwork. So as you can see, we have this sequence set up where one robot will support a member, and then one robot will place a member, and we take turns sort of assembling these rigid cells until we get to the end of the structure. Now, of course, as you can imagine, when you have more than one robot working on a structure, you have issues with path planning and collisions that could occur. So using the Compass framework and the Compass RRC control capabilities was essentially very pivotal to this. It's not something that a human could necessarily plan themselves. And as you saw in the video, there were some very funky, crazy moves that resulted from this path planning process. And yeah, I just want to thank all the participants. It was great to have their input and help in designing this fabrication process. And I think the result was successful all around.
Thank you very much, Edward. I also thought it was an amazing workshop. It was the one that I spent more time, perhaps, in tippy-toeing myself. It was wonderful. Thank you. Before we go into augmented architectural details, I want to send a message to Ethan, who's in the backstage. We are trying to promote you, but for some reason we cannot. Can we please ask you to just log out, close your Chrome, restart your stuff, and join the call again? There's something wrong on your technical side. Thank you. Jeffrey, augmented architectural details.
Sure. Can you hear me?
Yes.
Great. Hi, everybody. So my partner for this project, Ahmad, couldn't be here. But for this workshop, we taught students an introductory kind of crash course into the Unity video game engine. And they learned how to develop workflows for importing and editing three-dimensional geometry into Unity, and then developing interactions with it with the goal of producing AR apps. So they learned the development workflow for both iOS and Android devices. And we used a kind of Google Drive-based loading and importing process for them to share their work with each other. So by the end of the workshop, each student had built a iOS app, and they had the capability to create animated interactive architectural details Some students were working with robotics and previewing, doing path planning in AR. Some students brought in projects they were working on, like a trellis, for example, that you see here. And they were able to use this app to communicate construction logics to each other remotely. So in this case, the students were exploring a kind of miniature scale on their desktop, exploded model of a trellis structure. In other cases, students were previewing and seeing the construction logics for full-scale assemblies. So this is another kind of panel-based system, which you can see at full scale in this park. And you can see some of the kind of visual effects of the design as well as the construction logic. So the goal of the workshop was to kind of challenge some of the current typologies for explaining architectural design, and to kind of allow anyone with access to an iPhone to understand at full scale the design consequences or assembly logics of a particular design.
Beautiful. Thank you, Jeffrey. And Ethan, I'm very happy to see you back.
I made it. Thanks for having me.
Awesome. So this was distributed collaborations. Would you like to brief us into how the workshop went?
I would love to. Thank you so much to all the organizers and my colleagues, Professor Sigrid Belchochen, Johannes Brauman, Carl Singlein, Dr. Sven Stum, and all the people, all the participants especially. So I thought it was really interesting in the last workshop, in the last session, the workshop leaders talked about how they were sending instructions and material out into the world. And we kind of flipped that on its head, and we were looking for people around the world to send instructions to our robots. Similar to the folks at Princeton, we are very excited to live in this challenging time where digitalization is ever more important, and especially with regards to robotic fabrication, we still want to get people working and fabricating and learning about the future of construction in an automated way. So in our workshop, people from around the world were able to download a Grasshopper file and basically work with the next generation of KUKA PRC from the Robots in Architecture organization called KUKA CRC. KUKA Cloud Remote Control allows people to log in to robots all over the world. So people were able to switch back and forth from a robot here at the RVTL Aachen Chair of Individualized Production, where we have Optimus, this orange robot, or jump across across Europe over to Linz at the Chair of Creative Robotics, where they could work with their new KR5-driven robot. And so this was a really interesting chance for people to, from one file, work in 2 different locations. And it was just the most international experience I've ever had, where people from over, I think, 17 countries were able to pick and place a piece of rebar. And then that piece of rebar was welded in place, and that it was instantiated through the cloud to everybody else's model. So it was a very completely unplanned collaboration where one person could place a stick and that stick would appear in everybody else's model, and they could build on top of that. So it's a bit of a jumbled mess and it doesn't look like a pre-planned design, but when you look at each stick and say this one came from Japan, this one came from Chile, this one came from China, this one came from New York, it becomes a much more beautiful kind of artifact of architectural collaboration. And I think that bringing robotics to people and allowing them to work safely and socially distant, but still collaborate closely is really exciting. And yeah, I'm really looking forward to seeing where it goes in the future and to discussing it with the other workshop leaders focused on fabrication.
Amazing. Thank you very much, Ethan. I'm going to throw a question out there just because I was actually really happy to see so many workshops that were dealing with materiality in either remote forms, augmented forms, or purely digital forms. So I wonder, what do you think we're winning by doing all this digital augmentation of how we make things? And what are we losing when we use so much digital technology to make physical artifacts?
Well,
yeah, maybe I could, go ahead, Ethan. I'll jump in after you, no worries.
Sure. I mean, I think as architects and engineers, we're very used to leveraging a worldwide network of resources. And yet there's still a bit of a distance between the hands-on nature of how we're able to work with these tools, or how we're able to see our buildings manufactured. And so I think we're gaining a new form of digital craftsmanship, that a robot is a new form of chisel to a stonemason. A robot is a new form of paintbrush. And I think, so we're gaining a new form of digital kind of capability. With COVID, of course, we're losing or challenged to maintain this hands-on, feeling of the material. So I love how the other workshops were sending out mycelium or sending out crocheting. And I think it is hard remotely to see that the robot's about to crash into the table or something like this. But it's still fun.
Well, we didn't receive your application about sending robots to people.
Next time. Edward, sorry to cut you off.
Oh, no problem at all. Just to piggyback off that answer, maybe I'll tackle sort of the second part of the question, which is sort of what we're losing. Because I think, what we're gaining is, of course, this amazing opportunity to design and fabricate structures in ways we haven't really done yet. But I think what we're losing in some ways, and it's important to consider this always, is the access to this technology, right? There is definitely a power imbalance in who can access more and more advanced technology. And I think what I love to see in all these workshops was the fact that we're trying to now democratize this technology that was perhaps much more restricted before through these, collaborative processes, cloud computing, or trying to access something complicated, but with a very simple or simpler technology. And I think that is the direction most things are going towards, trying to open up the access to this technology. And of course, the more people that are using these things, the more exciting and the more interesting the work is going to ultimately be. It's just more stimulating for the computational design community in general. So I think it's very exciting to see all this work happen.
Should we be critical about the things that we might be losing? Maybe craft, maybe know-how, maybe some kind of skill?
I can jump in. I think with what Edward was talking about, with the increased difficulty maybe in accessing these types of technology, there also comes there come a lot of constraints. So any of these technologies, and specifically robots, as we work with them, they are highly constrained. They're not machines that can do anything. They're actually machines that can't do many things, and you have to learn to think in their workspace, to think in their constraint space, and that is a huge gap that opens up all of a sudden. So I think, since you're asking, are we losing craft? We're losing the closeness to actually doing the physical things directly without having to translate through a machine, which is highly complex and comes with lots of constraints. And I think there is still a lot to tackle to make that really to close this gap and be able to work and to be really aware of it. It's not necessarily about, hey, I want to work with a robot as if it was a human doing it. It's more about, I need to be really aware of these constraints and what this translation does. And I think the best is to combine the two and take the best of both options to not lose one or the other.
I think that in the future, there's a real synchronicity between the workshops that with the robots and the augmented reality workshops. And I think that it's really interesting to always think about accessibility to robots and this nature of getting your hands really dirty with processes. And I think that in the future, we will try to extend more and more augmented interfaces into these robot controls. So even if you can't have a robot in your desk, you could not just be looking through a flat screen, but be looking, around a 3D model, augmented maybe on your kitchen table, and then be building in a lab in Princeton or in Germany or in Linz or anywhere in the world. And I do think that it's important to think about accessibility absolutely to these processes.
And augment how we think and how do we design the physical construction of architecture, like for example in Jeffrey's workshop. Without the need to actually do physical work, correct?
Yeah, I also think, the ideas of accessibility and democratization are really important here. Beyond even fabrication, could someone have an architectural experience that couldn't otherwise have it? So I don't have the means to go somewhere and see something, but I could interact with some design that's being made somewhere, a design from the past or a design that is in the midst of being constructed from whatever, my apartment or a park across the street or something like that.
Awesome. Thank you very much, Jeffrey. And we need to move on. We have other workshops that we need to present. I would like to kindly invite you to remain in the backstage in case we do a final massive screenshot. Thank you very much. And I'm going to invite my colleague, June Grant, to join the stage and introduce the last block of workshops.
Thank you, Jose. How much time do we have for the session? Are we running late? Can someone let me know?
We have roughly 20 minutes.
Okay, we can do this. Perfect. Hi, everyone. My name is June Grant. I'll be moderating the last group of workshop summaries. And when we started, Benas looked at AI and the question of critical authorship and respondency. Verna looked at physical fabrication and making, and Jose just looked at tooling and augmented fabrication and new forms of craftsmanship, and the loss of access. And a last question that was just discussed, this lack of access in a new form of craftsmanship is fascinating. So I'm going to look at the next group. We're going to look at software and digital design, and let's see if we arrive at an answer at a more democratized process. We're going to look at workshop 5, building web-based drawing instruments, then workshop 9, physics towards critical assemblies, workshop 11, form finding staircases with Compass CEM, and our last workshop we'll take a look at is generative design and analysis in early stage planning with SpaceMaker. So I'd like to invite to the stage, Gallo, are you here with us to talk about workshop 5, building web-based drawing instruments?
Unfortunately, Gallo is not able to make it today, so we're missing Gallo.
Okay. Should we move on to the next one or just talk about it?
There is a video we can show. Next slide.
Perfect. Thanks, Vanessa. So I don't think this one is audio, so I will just describe. The workshop taught participants how to use the programming language of JavaScript P5.js to make interactive and dynamic web-based installations. And conceptually, it is to discuss the accessibility of open source design tools and programming as a liberating act. Participants were introduced to the freely accessible tools and methods of writing code, publishing that code, and deploying it to an online server. Programming was presented as a way of liberating oneself from the constraints of proprietary software. The goal was to explore what internet browsers and open source programming libraries can offer designers and architects from a critical perspective beyond utility. In a way, this workshop used online source codes as we do Pinterest, where we go on and kind of pick an image and use it as a source of inspiration. So this was quite fascinating, the results that came from workshop 5. We'll just watch it to the end.
We already did.
Okay.
We can move on to the next one. Thank you.
Perfect. In workshop 9, we looked at form physics towards critical assemblies. If I can invite that group to the stage. Is Daniela and Nicholas here?
No, they couldn't make it either.
This is unfortunate. Okay, I'll describe. The workshop explored procedural workflows by integrated Autodesk Maya, MASH, Grasshopper for polygon modeling, parametric design, and animation techniques using physics. The workshop demonstrated how a clear process can result in a variety of outcomes that can be further discretized, evaluated, and assembled into a final design proposal. The workshop focused on the object, both as a static and a dynamic entity. Workshop 11, are we still looking at workshop 9?
Welcome to our ACADIA 2021 workshop video. In this workshop, participants learned how to form-find staircases using the combinatorial equilibrium modeling framework and its computational implementation, Compass CEM, in both Python and Grasshopper. Compass CEM is a new design tool that uses automatic differentiation to generate elegant and efficient structural forms subjected to geometric and force constraints. To achieve the learning objectives of this workshop, we followed 3 main thrusts. First, we introduced the participants to the relevant theoretical background on form finding, graphic statics, and the CEM framework with a series of condensed lectures. We underscored the importance of the interplay between topology, form, and forces as design instruments. Then, to get practical experience with our software stack, participants were guided through a series of hands-on tutorials that gradually increased in complexity. We looked at 2-dimensional staircase models and explored together how the manipulation of the connectivity and the tension compression state of a structure can lead to geometric variations in the output form. We later studied more intricate 3-dimensional staircases that illustrated the possibility of combining tension hangers, compression arches, and diagonal bracing in the same structural system. Our Grasshopper live demos were accompanied by didactical whiteboard sessions that demonstrated how the CEM framework's theoretical concepts relate to the functions available in the tool. Finally, the workshop closed with a capstone project. With the assistance of the instruction team, participants used the tools and concepts learned to form-find the structural geometry of a staircase. In teams, participants chose to either model a new staircase or to replicate the geometry of an existing structure of their choice. Some of the teams designed pre-stressed stone staircases and bifurcating ramps, while others experimented with parametric variations of hybrid tension compression systems. We were all very enthusiastic about the capstone project presentations and the workshop outcomes. Thank you for watching.
Were any of the team members from Workshop 11 able to attend?
Yes, we're here.
Perfect.
Hello.
Hi. Thank you for making it. Can you talk about a little bit about the experience at hosting the workshop and what were the findings?
Yeah, well, maybe I start. I think the workshop was, for us, was very intriguing to see how the participants really engage with the tools. So it was not, it's not, I would say, so straightforward to start designing with a tool that is very much based on this topic of graphic statics, so requires certain backgrounds preparation. But all the students and the participants are really very much intrigued and started to play around with the tools, and they ended up with quite beautiful, very intriguing results with these staircases, things as also as instructor we really didn't have in mind from the beginning. So it was quite challenging bringing all together, since we had participants from all over the world. But I guess they managed to come together and to organize the teams and the groups so that they could work. I don't know what time during the day or night, but they ended up being very engaged.
Yeah, I can add to that and say that it was very nice to see everyone's engagement and to get to know a little bit of everyone's background too, and get to know the participants as well. So I think that exchange was also very nice.
Was this way of working remotely raising any new questions for you about how to engage participants with the tool, with the software?
Yes, well, it was quite interesting because it was not just about working directly with digital tools, but we had the chance also to start to discuss with the students and to sketch around with these, let's say, virtual sketchboards or whiteboards. And it was really very much an interaction with all the participants and everyone asking questions and then building up on what was discussed as an answer to one participant was the starting point for another questions. So it was really very much bringing together analog and digital tools in this workshop. So that was quite an interesting approach, as I think was made possible also by the fact that we were working remotely. So it was very fast interaction.
So it forced you to adapt.
Yeah, for sure. One thing that I also noticed from previous classes that I had remotely during this past year was how to get feedback from participants. So we used also Google Forms to see what was going on, because we don't get that little part in the end where you're just taking a coffee and you're just informally talking to people. So I think also that tool was helpful for us to get a sense of what they're feeling and how's it going.
Yeah, this entire conference is run by Google in the background. Thank you so much. And now we're going to pivot to our last workshop, workshop 13, generative design and analysis in early stage planning. And I invite Autodesk team, Zach and Lily, to talk about what their experience was like. And if we could show the video as well, that'd be wonderful.
Sure, thanks. Was a wonderful presentation and workshop as always. We've been doing them for a number of years. This year we wanted to really emphasize sort of a analysis forward and sort of cloud-based tool set, because we were all in different places, but we wanted everybody to really be able to work very closely together and really collaborate. And so the tools that we were working with were sort of a combination of sort of traditional manual modeling and always on, always available analysis tools, so that as you are going through the process of doing basically a planning process for early stage design, you get all the pieces of your design, but you always get analysis. And we wanted to sort of go through that experience with, you know, a distributed group, people from all over the world, but also what kind of analysis are going to be important to you, and how is immediately getting that feedback on the sort of the performance implications of your building going to change what you do as a designer. There is some amount of aspect in this design that's going to be automatically generated, but a lot of it that's also manual, and that sort of give and take. So we talked a little bit about theory, about how this stuff goes together. We generated a lot of designs and drew a lot of designs, but everybody was sort of, you know, 23 designers made 160 proposals, all working together at the same time. So none of this data was sort of left on anybody's desktop machine. It was all sort of pooled in this collaborative environment. And then we broke up into teams and sort of had a little competition at the end. One group presenting sort of a number of design criteria that they were trying to hit, and how they were going to measure to make sure that they are actually hitting those outcome goals. Another that was basically looking at how far can we get outside of the comfort zone of parametric tools into sort of sculpting tools, but still always be having that sort of analytic feedback on those sort of sculptural forms. One that was very much gold on how do we make a lot of money on this residential development, and keeping those eyes on those numerical outputs, things that are important for people to actually get stuff built, and always being aware of what those numbers were behind the design. And then I think there's one more design in here that was really about looking at a couple of sort of meat and potatoes kinds of analysis, daylight, views, walkability, and how you could get sort of 3 different groups that sort of did separate designs and then put them all together into the same space. So we had wonderful participation, 23 people all around the world, some people staying up very, very late into the night, and everybody coming up with some very unique designs, but always being able to sort of shift over and see what everybody else in the group was working with, because it was all backed by running off of, you know, servers somewhere else, and people were actually able to show up with whatever kind of machines they needed to, because basically it was sort of a, you know, an interface to then have everything running in the background, including your analysis, including your modeling, so that you could sort of have that fluid relationship between I'm going to do a design move and I'm going to see my analysis all at once. Lily, I don't know if you want to add anything. We had a number of people. We had Michael Dewberry, Christoph Becker, Heather Leck, and my colleague Lily Smith, who's here with me now too.
We were also very excited to have June in our group participating. She was great. We were all kind of actually learning SpaceMaker. You know, it's new to Autodesk, and it was really fun to be able to see it through the students' eyes and participate that way.
Great. I do have one question for you guys, since your workshop was the one I did take, but also it's interesting, a prior question about, are we losing something, whether we go further into AI, whether it's digital fabrication. And I have the same question for Spacemaker, as much as I love the transparency of being able to see many of us working on the same model real time. Are you receiving any questions about how do we integrate greater authorship, critical analysis, critical thought before into the feedback as we're using Spacemaker? Like, where's that trace, that immediacy of trace within Spacemaker? Are you seeing more questions for requests for that, or what is your experience so far, since we're all learning to use Spacemaker?
Yeah, I mean, I think one of the key things that we said in a description of our workshop was, how do you keep control when you're kind of in this world of AI and things can be generated for you, or you can kick off things to generate for you. But how do you kind of maintain this control over the design and steer it in certain directions, use what it's telling you to go in directions that you think are better.
Yeah,
is that what you meant by that question?
Exactly. Yeah, your software actually made it so easy to click the button versus all the other workshops where you actually are actively coding. This makes it, this program makes it so easy to just accept what's given. So if you're not critical, and because you're not writing code, I challenge, like, what am I losing in that ease? What am I giving up? What am I not able to do?
I think we saw that too. You were commenting on some of the, understanding how the analysis is working is of critical importance, right? And a lot of the assumptions of the analysis in this case are based on people who are doing this analysis in the Nordics, and they like sun on buildings a lot of the time. You were coming from Southern California and saying, oh, that much sun would be bad. I would want that to be a different color, and and look at that in a different way. So I think understanding those assumptions, I mean, that's just one kind of simple example, but is really important, and also to maintaining that control. I don't know, what would you add, Zach?
Yeah, I mean, one of the things that's very clear about Spacemaker is that it's right now, we are constantly expanding this, and you're going to actually keep your eyes on this space because there's going to be a lot of changes coming. It's very boxy, right? You're drawing some things and you're getting some extrusion buildings. It's early stages, feasibility studies, it's early planning, and having that sort of simplified geometry that allows you to sort of know performative aspects right away is really sort of the foreground of it. We are getting a lot of requests for sort of increased expressiveness of the design tools, and there's actually some very interesting projects that we're working on with that right now. But it's about the outcomes. It's about the predicted performative aspects of these building blocks, and there's sort of a shockingly low level of detail that you need in order to get really good predictive results, and sort of that's the sacrifice at the moment is having relatively controlled levels of geometric representation that do give you wonderful sort of directional information about the big massing moves, the big layout moves that are really going to be the things that impact things like energy use intensity, your carbon footprint on the site for sort of embodied carbon, the things that are going to impact whether or not people actually have daylight in those boxes when you actually sort of fill out the details of what they're doing. All of that information gets set down very, very, very early in the design stage.
Perfect. I think we are out of time. Can someone tell me? And if we are, could I invite everyone to the stage so we can take our social media photo for one? Proof that we exist.
Can we ask the
open on your
technical
cameras?
Yes. Can we ask the technical team to promote?
And the technical team.
To promote everyone on stage.
Let's see how small we can make these windows.
We're definitely determined to break this platform today.
But the text doesn't shrink. We have to go back into the box and change the algorithm.
Outstanding.
Oh, this is fantastic. Are we all here? Technical team?
No, just wait a little.
Okay.
Two more.
There you go. This is beautiful.
Very
All
nice.
right. Can I get a waving from everyone? Thank you. Hey.
Did you do it, Jose? Okay.
Yes, beautiful. You're all
Perfect.
beautiful. We're all so thankful for your contribution and for making this community.
One more.
All right.
Jose, one more thing before everyone goes. There is a Wonder Room that we are putting it in the chat. This is for social networking. So please join us in the Wonder Room. This is not the networking in the platform. It's a different link. So we are just putting it in the chat. If you have time, join us.
And
bring
also,
a glass. Only party.
A final reminder, the exhibition with the work of the workshops will be opening tomorrow after the last panel of the conference. So if you want to see the results, etc., we will have an informal opening ceremony tomorrow after the panels. Thank you very much, everyone.
Thank you, everyone. This is wonderful. See you tomorrow.
Bye.
Thank you. Bye.
Bye.